I'm making this short screencast to explain how you can calculate the expected value or mean of a binomial distribution with a shortcut and also its variance. So to calculate these things, you'll basically be using two formulas that you can find in your formula booklet. We'll talk through why they make sense. I'll show you an example of how to do each of them. For expected value or for mean, you multiply the number of trials times the probability of success on any given trial. So here's what that means in practice. Suppose we have a multiple choice test that has 20 questions, and this time it has 4 answer choices like A, B, C, D. So if we guess at random, we'd like to figure out how many we'd expect to get correct on average. Using our formula for expected value, we multiply n times p, so we just need to figure out what n and p are in this situation. You get this nice live action. It's almost like you're here with me, fumbling with technology. In this case, x is counting the number of correct responses. N is the total number of trials. We have 20 questions, so n is 20. There's 20 possible questions or responses, and then we have a 1 in 4 chance of getting it correct since we're guessing at random. So our p is 1/4 or 25%. That means that on average, we would expect to get 1/4 of 20 of them correct. So 20 times 1/4, or 20 times 0.25, which is 5. And we can interpret this by saying that on average, we'd expect to get 5 questions correct if we repeated taking many multiple choice tests with 20 questions and a 1 in 4 chance of getting them correct. That's all for expected value. Notice that it's not the same as how you calculated expected value for just any old discrete random variable, where you had to multiply each outcome times its probability and add them up. Now you've got a shortcut. Same thing with variance. So we haven't talked about a variance of a random variable yet, but essentially it means the same thing as the variance in statistics. So remember that variance measured the spread of outcomes. In statistics, it was the square of the standard deviation. So I've illustrated graphically what we mean by the spread of outcomes. On the left, we are flipping a fair coin 5 times and counting how many heads we get. And then on the right, we're flipping a coin, but this time 10 times. So you can see that if we flip the fair coin only 5 times, we could have any outcome between 0 and 5, whereas 10 times, we obviously have more outcomes. That means that as we increase the number of trials, we also increase the variance, because here we have a spread of 11 possible outcomes, and here we have 6 possible outcomes. Another factor that affects the variance is the probability of success, p. So consider on the left here, if you have a coin that has only a 10% chance of landing heads, that means most of the time it isn't going to land heads, it's going to land tails. So if you're counting how many times it lands heads, you would expect that you probably are only going to get 0, 1, 2, or 3, a small number of successes. Versus if the coin is fair, and you have a 50-50 chance of landing heads, then you have a wider spread of possible outcomes, because it's possible you could get 5 heads, 5 tails, but it's also not that unlikely that you would get 4 and 6, or 3 and 7, and so on. So the variance will also depend on p, the probability of success. And the exact formula that calculates the variance or spread of your variable is on this next slide here, and it's also in your formula booklet. We won't prove it rigorously, but we now have an idea that it should involve both n and p. And it is similar to the expected value, except you're going to multiply n times p times 1 minus p. Here's what that looks like down in the slides below. If we go back to the multiple choice example, we're taking the test. In this first example, we have 20 questions, just like before, and a 1 in 4 chance. To calculate the variance of that variable, we would take n, which is 20, times p, which is 1/4, and then times 1 minus p, so that's 1 minus 1/4, or 0.25. That gives us 0.75, and then we multiply all 3 of those things together in calculator and get 3.75. If instead we've got 10 questions instead of 20 questions, you can imagine there's fewer questions, so there'd be a smaller variety. or spread in your possible outcomes for how many questions you get correct. And indeed, when we calculate the variance here, p is still the same, so we still have p times 1 minus p, this time times 10, and we end up with half the variance that we previously had. That's all for expected value and variance. You should be able to calculate both of them once you know n and p, and remember that your formulas are in Formula Booklet.